It's not just a star. What do we see in James Webb's first image? The James Webb Space Telescope, or JWST, is a device worth $10 billion. What is so significant about the first image it captured? How far is it from the Earth? Is it just a star or more? What is seen in the first image other than the star? Hello guys, and welcome back to Space Webb. Today, this informative video is based on some cosmic discoveries. Let's dive into the content. Trust me, after watching this video, you would undoubtedly find it informative. The very first images are a clear demonstration of James Webb's capabilities. Amazingly, yes, the worth of this device is $10 billion, which is currently 1.5 million kilometers away from the Earth. It is 100 times more sensitive than Hubble, and operating in the realm of infrared, Webb is already capturing distant galaxies. There's no way that Webb can look for 2,000 seconds at any point in the sky and not get an incredibly deep field, Rigby says. This is going to be the future from now on. Wherever we look, it's a deep field. Without even really breaking a sweat, we are seeing back in time to galaxies that we're seeing the light as it looked billions of years ago. James Webb consists of 4 scientific instruments, from which only one is currently operational, which is the Near Infrared Camera, or NIR cam. With the help of this NIR cam, the first image was delivered. The first image captured by the James Webb Space Telescope is the star with the catalog number 2 mass J17554042 plus 6551277 from the Milky Way galaxy. After reaching its orbit in the second Lagrange point, or L2, Webb captured its first target star, HD 84406. It's a bright star that is 16 times brighter, with a similar temperature, and is about 4.4 times the size of the Sun. There is nothing intriguing about the star known to astronomers, but it is significant. It is located in the constellation Ursa Major, about 260 light-years away. But it's just one of up to 400 billion stars in the Milky Way, and until recently, nobody gave it a lot of thought. It's a perfect target for Webb to collect engineering data and begin mirror alignment, said JWST scientists Jonathan Gardner and Alexandra Lockwood. According to NASA, the James Webb Telescope captured the star with a red filter to enhance its brightness, but the resulting image does not show the beauty of the cosmic depths. Yet it's the highest quality and resolution infrared image we have ever made in space. Lee Feinberg, the NASA engineer who was in charge of the development of James Webb's optical elements, believed that the very first properly focused image was phenomenal. You not only see the star and the spikes from the diffraction of the star, but you see other stars in the field that are tightly focused, just like they expect, and all sorts of other interesting structures in the background, he told reporters. This is another proof of how powerful the Webb telescope is. You can also see the structures in the background, which are distant stars and galaxies. At times, it is the background that makes a photo famous. So what is behind this unremarkable star? One of the distant galaxies in the background is about 5 billion light-years away from us. These are only the primitive observations of the new Space Observatory. Scientists have only checked how well the telescope can focus on a star, and as a first result, it managed to see objects located 5 billion light-years from us. NASA has also released a new telescope selfie, which was taken with a real infrared camera. It captures the uniformity of illumination of each of the 18 segments of the primary mirror instead of an image in the sky. In the coming months, there will be more adjustments so that the segments become an almost single whole. James Webb has everything needed to detect extraterrestrial life. Even it can finally put an end to the burning dispute of whether it exists or not. Thousands of scientists from all over the world worked on the creation of the James Webb Space Telescope for 25 years, and $10 million were spent. To build such a sensitive device, it was necessary to create the most complicated folding mirror consisting of 18 hexagon segments. It was launched on December 25, 2021. When the powerful Ariane 5 disappeared behind the clouds, thousands of people silently prayed. The telescope is high as a 3-story building and an area of the parking lot for 20 cars had to be brought into working conditions in space without human participation. And not only did it have to deploy the sun shield and mirror, but also adjust 18 segments that make up Webb's 6.5 meter or 21 foot 4 inch diameter mirror that are driven by actuators that allow them to move in 7 axes. Each segment works as its own independent mirror, meaning that, left to themselves, they would capture 18 hazy images of a single body instead of one extraordinarily sharp one. This is thousands of times thinner than human hair and billionths of a meter. It was then when the first good news in February came that it captured its first image. All 90 cables and 107 launching devices worked flawlessly. The telescope was first used to capture the famous Large Hadron Collider, which is almost 27 kilometers or 16.7 miles, and made it possible to discover the famous God particle, the Higgs boson. After assembling the James Webb Space Telescope, the project team needed to confirm several things. They had to make sure that the near-infrared camera, or NIR cam, was ready to collect light from the celestial object and then identify starlight from the same star in each of the 18 primary mirror segments. The result is a mosaic of images of 18 randomly arranged points of starlight. The device started to collect images on February 2nd, and 1,560 of them were generated using 10 NIR cam detectors. The whole process took almost 25 hours and resulted in 54 gigabytes of raw data. Finally, the James Webb Space Telescope is what's known by astronomers as a dust buster. Even as the JWST works to hone its vision, a second key process is taking place in the background as the observatory sends the remaining heat from its time on Earth out into space. Because Webb is tuned to study the universe in infrared light, which also registers as heat, the observatory must be incredibly cold to obtain accurate data. NASA scientists expect the golden primary mirror will reach temperatures as low as minus 370 degrees Fahrenheit or minus 223 degrees Celsius or 50 degrees Kelvin. Instruments must be even colder, according to an agency statement. The James Webb Space Telescope managed to pose beautifully against the background of the stars, which was captured by another space telescope, Gaia, which has been orbiting the same Lagrange point as the Webb, taking a full service of the night sky every few months. On February 18th of this year, the two spacecraft were at a distance of 1 million kilometers. The Gaia observatory camera took a picture that shows a very faint speck of light in the James Webb Space Telescope. This was made possible due to the hyper-reflective mirror series that the Webb telescope is equipped with. The overall focused image is a very important stage in the preparation of the telescope, but the real break in scientific discoveries can be expected by mid-2022 when the TELES starts to take pictures at the maximum resolution and then all the instruments start collecting additional scientific data. But what will NASA's experts look for during the first year? James Webb's first targets will include small galaxies in the area of the remixes of excluded stars and the oldest stars in the universe. The James Webb Telescope can be considered a time machine that would allow humanity to look back 13.5 billion years. According to modern concepts, the universe was frequently observed about 13.799 billion years ago. The difference is just some 300 million years, and that compared to almost 13.8 billion years is only 2% of things that the telescope would be able to see that could be the most interesting problem that ever happened during the birth of the very first galaxies and the formation of our universe. We hope that in a couple of decades, we'll be able to create a telescope that will observe the remaining 2%. If we succeed in doing so, we will not only see how the galaxies and stars were born, but also what made it happen. Scientists also would like to learn about supermassive black holes and how they formed at the center of the galaxy. Since we have already figured out the way ordinary black holes appear, it's still a mystery when it comes to supermassive black holes. One theory is that it's possible many black holes merge, but we have no clue about the hidden number of them and how it could gather at one place at an early stage of the universe. So, this was all about this video. I hope you liked the information given in the video, and if you have anything on your mind, feel free to comment below. Also, don't forget to like, share, and subscribe to get more videos like this. Also, hit the bell icon to get the notification of the latest updates on the channel, and thanks for watching!